Skill 13, Proving Lines Parallel. Example 1, we're just going to identify parallel lines. Okay, which lines are parallel if we know that angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. Okay, so we want to know which two lines are parallel. Well, if the line A right here and B right here, and then if our transversal is line M, then we see that our corresponding angles are 1 and 2. And we know that if we have corresponding angles, then the lines have to be parallel. So that would mean that A and B are the parallel lines. So we know A is parallel to B because angle 1 and angle 2 are corresponding angles. This is true by the converse to corresponding angles theorem. For example 2, we're going to do a proof. Given the measure of angle 3 plus the measure of angle 6 equals 180, prove that line L is parallel to M. Okay, so in a proof we always start with what we're given. So the measure of angle 3 plus the measure of angle 6 equals 180, because that is given to us. Okay, the next part is, this is where we could do a couple different things. But what I'm going to look at is, if I look at 6 and 7, those form a linear pair. And if they form a linear pair, then they are supplementary. So I'm going to go that direction next. The measure of angle 6 plus the measure of angle 7 equals 180 by the linear pair postulate, or the definition of supplementary angles. Okay, now next I have two things that are set equal to 180 degrees. Since both of these things equal 180 degrees, that means I can set them equal to each other. So that's going to be my next step. That tells me that the measure of angle 3 plus the measure of angle 6 equals the measure of angle 6 plus the measure of angle 7, and that is by algebra, the transitive property. Okay, the next step is, now we're going to do a little bit more algebra, because there is a measure of angle 6 on both sides of the equal sign. We can get rid of those. So we have the measure of angle 3 equals the measure of angle 7, and that's by algebra, the subtraction property. And now I can convert that into congruence, because I know things about congruence. I can prove things about parallel lines by our converse theorems. So that's what I'm going to do now. So angle 3 is congruent to angle 7 by the definition of congruent angles. Now if I look at angle 3 and angle 7 in my picture, angle 3 and angle 7, those are corresponding angles. So by the converse to the corresponding angle theorem, we can say that line L is parallel to line M. So line L is parallel to line M by the converse to corresponding angles theorem. And then we are done. For the next example, we're going to prove the value of x given A is parallel to B. Okay, so in these cases, these are those algebraic proofs that we've been working on. So given A is parallel to B, angle 1 equals 2x plus 9 degrees, and angle 2 equals 111 degrees. We want to prove that x equals 30. So my first step is to list out what I am given. The next step, we have to look to see what we can do with this information. Well, I see that angle 1 and angle 2 are same side interior angles. So I would maybe use the same side interior angle postulate to do what I can with that. So I know, based on that postulate, that I can add those two angles together to get 180 degrees because they are supplementary. So that's my next step. So we have the measure of angle 1 plus the measure of angle 2 equals 180 by the same side interior angle postulate. Okay, now the next step, since I have measure of angle 1 and measure of angle 2, I can put in what I know about those two angle measures. And what I know is that angle 1 equals 2x plus 9 and angle 2 equals 111. So that's what I'm going to do. So 2x plus 9 plus 111 equals 180, and that's by algebra substitution. The next thing is to simplify the algebra. So I'm going to put the 2x plus 9 with the 111 and simplify that. 2x plus 120 equals 180 by algebra and combining like terms. So the next step is to get the 120 away from the x term. So we have 2x equals 60, which is algebra subtraction property. And the last step is to get the x by itself. We have x equals 30, which is algebra, the division property. And now we have proved that x equals 30. For this last example, we are going to prove another algebraic proof. Given A is parallel to B, angle 1 equals 55 degrees, and angle 2 equals 3x minus 2 degrees, we want to prove that x equals 19. Okay, so again, we start with what we are given. So we have A is parallel to B, angle 1 is 55 degrees, and angle 2 is 3x minus 2 degrees given. Next step is to see what we have and what we can do from there. So what I have is angle 1 and angle 2. Those two things are corresponding angles. So if I look back at my theorems, I should see that corresponding angles are supposed to be congruent to each other. So that's the next thing that I'm going to say. So angle 1 is congruent to angle 2 by the corresponding angles theorem. The next thing we're going to do is we're going to change it into angle measures so that we can actually use our numbers. So I'm going to, instead of writing angle 1 and angle 2, I'm going to write the measure of angle 1 equals the measure of angle 2. And that is by the definition of congruent angles. Now that I have my angle measures, I can plug in what I know, which I know that angle 1 is 55 and angle 2 is 3x minus 2, so put them in where they belong. So that gives me 55 equals 3x minus 2, and that is by the algebra substitution property. So that's what I'm going to put there. And now I'm going to solve the algebraic equation like I always do, giving me 57 equals 3x by algebra, the addition property. And the final step is to solve for x. So x equals 19 by algebra, the division property. And now we have proved, given the two corresponding angles, our x equals 19. So that is your notes for Skill 13, Proving Lines Parallel. Summarize your notes, do your practice problems, and then you might be ready for your quiz over this material.